Hello friends, welcome again to this channel. This is G Solutions, where we find solutions for your needs. So we are on alternating current, circuit analysis, and so we have to differentiate the direct current and alternating current polarity marker. The first one that we should know is that the battery has a fixed polarity, and this can be determined from the symbol, from the circuit symbol. So for instance, this one is a DC voltage source, in which we identify as the short segment here as the negative and the longer one is the positive. So again, we can distinguish the negative and positive through the schematics symbol. So we can connect a battery in series or in parallel by considering the polarities of the terminals of the battery. Let us always remember that if you are going to connect battery, for instance, this is negative and positive, and you connect another battery here which has a polarity of this one. This is negative and positive. You connect these two, so you will have a DC voltage source aiding. Okay, so you will notice that positive here is connected to negative, and this one is negative and this one is positive. So since it faces on the same polarity, so it will be aiding. But if you are going to connect this battery like this one, wherein this is positive and this is positive, negative, negative, connect this one, so this will be subtracting, so this one is aiding. So you just add the two voltage source, and this one is subtracting. Okay, you just take the difference of the two sources. So that's how you have it connected in a direct current source. But in an alternating current source is quite different, because in an alternating source, the polarity is alternating. So each terminal is positive, half of the time, and the other half of the time is negative. So after it has been negative polarity, after some time it will be positive. So it is changing. Okay, so positive half of the time and negative half of the time, or negative half of the time and positive half of the time. And that's why we have a schematic symbol of this one. It means it is alternating. Okay, and we can place the polarity here, positive and negative. So we put it on one side. So that's for number one. And for number two, in our direct current circuit, wrong polarity will result in a negative computed voltage. Okay, so a negative polarity, it can be considered as wrong polarity in a DC circuits. But in our alternating current, a negative computed voltage, if the result is negative, it can be avoided. We should just adjust the phase angle. We have so-called the phase angle. Since that the polarity is changing, so you just have to adjust this one, and the negative result will be corrected, no? So half of the time it may be incorrect, but half of the time it will be correct. Okay, and number 3 that we should note is that in the direct circuit direct current circuit analysis, we deal with fixed voltages. So in DC, our voltages is fixed, while in AC, okay, we deal with voltages, polarities, and current directions at arbitrary time constant, arbitrary time. So take note that at a certain mentioned time, or at an instant of the time, the voltage polarities changes. It is subject to the time advances. So our polarity will be dependent on the time instant mentioned. And for number 4, that we should note regarding the polarity marker is that the power generated or dissipated by a circuit element in a direct current circuit is constant. So speaking of the power, whether it is generated or dissipated, this is from the source, and this power is because of the passive element connected to your circuit. Okay, so this power is constant. Okay, constant. While in an alternating current, this is in DC, while in an alternating current, the power generated or dissipated depends on the values of the voltage and the current at a given time instant. So this power generated or the power dissipated in AC is dependent on the given time instant. Okay, so we always deal here with the average power. Okay, so these are the things that you have to consider with regards to the polarity marker. Okay, so thank you for watching this video.